Reactions of haloalkanes. After the preparations and physical properties of haloalkanes and haloarenes, the reactions of haloalkanes. The reactions are nucleophilic substitution reaction. Second one is the elimination reactions. Third one is the reaction with metals. Nucleophilic substitution reaction means alkyl halides reacts with nucleophile, gives nucleophile substituted compounds. In this reaction, Nu is the nucleophile, X atom is the leaving group. In place of X, Nu is substituted. Okay, it's alright. Here general example Rx plus Nu gives rise to Rnu plus X. In the nucleophilic substitution reaction, carbon and halogen bond. Here carbon gets a partial positive charge and halogen gets a minus charge. The nucleophile Nu is attacked at the site of carbon bearing the leaving group which has positive charge. Okay. Here nucleophilic substitution reaction means nucleophile substitute the halogen atom. This substitution reaction takes place in two types of reactions are there. SN1 reaction means the substitution nucleophilic unimolecular reaction. Substitution nucleophilic unimolecular reaction. The rate of reaction depends on the only nucleoalkyl halide. Only alkyl halide. In SN1 reaction mechanism, the rate of reaction, the substitution, the nucleophilic substitution reaction, the reaction in which the rate of reaction depends upon the only alkyl halide is called substitution nucleophilic unimolecular reaction. Substitution nucleophilic unimolecular reaction. That means the rate of reaction, the reaction in which the rate of reaction depends upon the only concentration of the alkyl halide. Hence, they are called substitution nucleophilic unimolecular reaction. So, tertiary alkyl halides undergoes rate is equal to K into concentration of alkyl halide only. Therefore, it must be follows the first order kinetics. First order kinetics. Why it is the first order kinetics? Means the rate of reaction depends upon the concentration of alkyl halide. Right, understand? So, for example, tertiary alkyl halides undergoes SN1 reaction. Why? Because they form stable carbocation. The order of reactivity of alkyl halides towards the SN1 reaction are 3 degree alkyl halides greater than 2 degree alkyl halides greater than 1 degree alkyl halides. The example of this SN1 reaction is tertiary butyl bromide. Reacts with NaOH gives tertiary butyl alcohol. For example, the reaction I can write here CH3 CH3 Br reacts with what? Nucleophile OH minus, which is coming from aqueous NaOH. So this OH group comes at the in place of Br. Then there are two possible products are formed, CH3 CH3OH plus and CH3. That means there are two possible compounds are formed. Why? Because nucleophile, this reaction takes place in two steps. This reaction takes place in two steps, so that it is a possibility of attachment of OH group on the right side or left side, so that the configuration of first product is similar to configuration of reactant. Then the compound is said to be what? Retention configuration, and the configuration of second compound is opposite to that of what? Reactant. Hence it is said to be what? Inversion configuration. The mechanism of this reaction mechanism is takes place in two steps. In the step 1, here what will happen? Formation of carbocation will takes place from alkyl halide. Formation of carbocation. I want to take tertiary butyl bromide. This is the what? Your tertiary butyl bromide. CH3 Br. Tertiary butyl bromide reversibly gives rise to. This is the slow step of reaction. Then we will get tertiary butyl carbocation. This is the carbon positive charge. Then we can say it what? Carbocation. Carbon having positive charge. Carbocation we can say it. Next step. Step 2. The carbocation is attacked by nucleophile. Then we will get products. So this carbocation I can write like this: CH3. This carbocation is the what? sp2 hybridization and planar structure. This nucleophile attack on either side of the carbon. So suppose it attacks at the it is attached at the right side, the compound formed like this, OH plus. Next, if compound is attacked in this direction, opposite direction, then we will get OH CH3. Right? Understand? This is the what? First product. This is the what? Second product. Two products are possible. Why it is possible? This nucleophile attack on left side or either right side. Why? Because this is the what? sp2 hybridized carbocation facilitate the nucleophile to attack either side of the carbon. Therefore, there are two compounds are formed. First compound has similar structure of reactant. Then this configuration is said to be retention configuration. Retention means what? The configuration of compound is similar to that of configuration of product is similar to that of reactant is said to be what? Retention configuration. Retention Retention means what? Reoccur the same configuration. Then second compound is inverse configuration of what? Reactants. Then this is the what? Inversion configuration. Inversion means what? Opposite to the what? Opposite to first one. So this if alkyl halide is containing asymmetric carbon, the compound forms are D configuration and L configuration. D isomer and L isomers are formed. If alkyl halide is having unsymmetric carbon. Unsymmetric carbon means what? The carbon having 4 different atoms or groups is said to be what? Asymmetric carbon. Then the products obtained are optically active. These optical active compounds may be classified as D isomer and L isomer. L isomer. L isomer. That means what? Here dextrorotatory compound. This one is the what? Levorotatory compound. By the mixing of these two compounds, we will get what? Racemic mixture. The racemic mixture is formed. Racemic mixture means what? 50% D isomer and 50% L isomer is said to be what? Racemic mixture. So, in the SN1 mechanism, the stereochemical aspect of this SN1 mechanism gives what? Racemic mixture. That means D isomer is possible and L isomer is possible. Equimolar mixture of D and L configuration is said to be what? Racemic mixture. This we studied about the SN1 reaction mechanism. Then the factors affecting the rate of SN1 mechanism. There are 8 factors are there. 8 factors. First factor is the leaving group. Leaving group means what? Here. So you know that alkyl halide reacts with what? Nucleophile gives or Nu plus X. X is the leaving group. So the leaving group size will be increases. That favors the what? SN1 reaction mechanism. For example, alkyl fluoride, methyl fluoride. I want to take methyl fluoride. Size is less than methyl chloride is less than methyl bromide. Methyl bromide less than methyl chloride less than methyl bromide. Methyl bromide is less than methyl iodide. So which one is the highest leaving group? Means what? Iodide. Why? Iodide is the what? C-I bond is very weak and then it is easily leavable. So that leaving group favors the SN1 rate of reaction. Next one is the what? Nucleophile. We know that SN1 reaction followed by tertiary alkyl halide, the rate of reaction of SN1 reaction, the rate of reaction depends upon the only concentration of alkyl halide. There is no depending upon the concentration of nucleophile. So that nucleophile does not affect on the SN1 reaction. SN1 reaction. Nucleophile does not affect the SN1 reaction. Why? Because the rate of reaction depends upon the only concentration of the alkyl halide, not depends upon the concentration of nucleophile. Right? Understand? Next, third influencing factor on the rate of reaction, number of alkyl groups on the carbon having what? A leaving group. If number of alkyl groups increases, then rate of reaction will be increased. Why? Because the stability of carbocation will be increased. For example, I want to write RCl or CH2X. Here RX I will write RX is less than or CH2X less than or CH or dash X is less than or C or dash or double dash X. Here this carbon having leaving group containing 3 alkyl groups. If number of alkyl groups increases, the rate of SN1 reaction increase because of stability of carbocation, due to formation of stability of carbocation. Then fourth influencing factor, solvents. The solvents for SN1 reaction is polar protic solvents. Polar protic solvents are good for SN1 reaction. Polar solvents are water we have to take. This polar solvent solvate the carbocation and form the hydrogen bond with a leaving group. Therefore, the solvents is also one of the influencing factor on the rate of SN1 reaction. Polar protic solvents are very suitable or very good solvents for SN1 reaction because of solvate the carbocation, formed carbocation and forming hydrogen bond with a leaving group. Students, we learned the influencing factors on the rate of SN1 reaction. We discussed about the 4 factors. Next, fifth one is electron donor atom. If electron donor atom is present at the alpha carbon, then it increases the stability of formed carbocation, hence the rate of reaction will be increased. Suppose I want to write this electron donor atom like this. This is the alpha carbon has electron donor atom. The formed carbocation stabilized with this electron. Therefore, electron donor groups present at alpha carbon which facilitate the rate of SN1 reaction. Then vinyl and aryl halides do not follow the SN1 reaction because vinyl halide means vinyl chloride I want to take here, CH2 double bond CHCl, and aryl halide C6H5Cl. Here the formed carbocation does not stabilized, so that they do not follow the SN1 reaction. Then there is a CO group is present at the beta position. Beta position will decrease the does not give the SN1 reaction. Suppose I want to take this one CH3CO CH2Cl. Here this is the alpha carbon, this is the beta carbon. Beta carbon is the CO group. This CO group is said to be carbonyl group. Right? Understand? If here in the SN1 reaction formed carbocation is not stabilized with carbonyl group which is present at the beta position, so that this does not undergo SN1 reaction. Do not react. Why do not react? Because this carbocation destabilized with electron withdrawing group. Right? Understand? Next, allylic and benzylic halides are readily undergoes SN1 reaction because the formed carbocation stabilized by resonance. I want to write allyl chloride. Allyl chloride means CH2 double bond CH single bond CH2Cl. Here the carbocation, allylic carbocation formed CH2 plus. This carbocation stabilized by this pi electrons. Hence, the carbocation formed stabilized with pi electrons or resonance, we can say it. Hence, allyl halides undergoes SN1 reaction. Next, benzyl halide. I want to write benzyl chloride. CH2 C6H5CH2Cl. This forms C6H5 CH2 plus and Cl minus. Here the benzyl carbocation is also stabilized by resonance. Hence, this allylic and benzoylic halides are readily undergoes what a SN1 reaction because the formed carbocation is stabilized with resonance. SN2 reaction. What is meant by SN2 reaction? S means what? A substitution. N means a nucleophilic. 2 means what? A bimolecular reaction. Substitution, nucleophilic, bimolecular reaction. Bimolecular reaction means what? The rate of reaction depends upon the substrate and nucleophile. Is called what? A bimolecular reaction. So SN2 reaction means the substitution reaction in which the rate of reaction depends upon the both alkyl halide and nucleophile. Hence, it is said to be what? Substitution nucleophilic bimolecular reaction. So, the rate of reaction is R is equal to K into concentration of alkyl halide and concentration of nucleophile. So, rate of reaction depends upon the concentration of alkyl halide and concentration of nucleophile. Hence, it is said to be what? SN2 reaction. SN2 reaction. Right? Understand? So, which type of alkyl halide which undergoes SN2 reaction means primary alkyl halide. Primary alkyl halide undergoes SN2 reaction. SN2 reaction because due to less steric endurance. Steric endurance means what? Bulky groups are now should not be present on the halogenated carbon. Then only this undergoes what? SN2 reaction. So next one is we can say the order of reactivity of alkyl halides. Order of reactivity of alkyl halides for SN2 reaction. Alkyl halides are 1 degree is greater than 2 degree is greater than 3 degree. That means primary alkyl halides greater than secondary alkyl halides greater than tertiary alkyl halides. Taking example 1, methyl chloride CH3Cl reacts with what? OH group. Then we will get a substitution will be takes place CH3OH plus X minus. Here the nucleophile and methyl chloride, alkyl halide and nucleophile. The rate of reaction depends upon both of these two, alkyl halide concentration and nucleophile concentration. Hence, it is said to be what? SN2 reaction. Right? Understand? So, the reaction follows the SN2 mechanism. The mechanism takes place in only one step through the transition state as an intermediate compound. Of SN2 reaction, the reaction takes place between the methyl chloride and OH group of NaOH. This reaction the mechanism takes place in only one step reaction. This bond, CLX bond, it is the leaving group and this is the nucleophile. Nucleophile attacks the carbon of leaving group or leaving halogen leaving group in the opposite side of the this leaving group. Here like this. This is the leaving group this one, and this one is the nucleophile. The bond breaking of Cl bond breaking is takes place and COH bond is also formed. This is state is said to be transition state. That means there is an intermediate state. Intermediate compound is formed. This intermediate compound firstly the Cl bond is broken and Cl minus is formed and new bond is formed. This here, the product formed is opposite to the configuration of what a reactant, methyl chloride. Methyl chloride configuration, and this product methyl alcohol configuration, methyl alcohol configuration, are both are opposite. Why? Because here leaving group is right side and nucleophile attacks form the bond at left side. Therefore, both the product structure is opposite side of the what leaving group. This will be takes place simultaneously. Bond breaking is takes place and bond forming is takes place simultaneously, and to form what methyl alcohol. This methyl alcohol configuration is opposite side of the opposite of the what methyl chloride. Hence, this configuration is said to what inversion configuration. Inversion configuration. The factors affecting the rate of SN2 reaction. There are 6 factors are there. First one is the what nature of the substrate. Nature of the substrate is what the relative order of reactivity of alkyl halides are methyl halide CH3X is less than 1 degree is less than not less than greater than this one. 1 degree is greater than 2 degree is greater than 3 degree. As the number of alkyl groups increases, the rate of SN2 reaction decreased. But lighter groups only one alkyl group, methyl halides, are more reactive towards the SN2 reaction because the steric hindrance is less. The leaving group means X is the size of the atom. X atom will be increased, then rate of reaction SN2 reaction is also increased. For example, CH3F is less reactive towards the SN2 reaction. CH3F less than CH3Cl less than CH3Br less than CH3I. Right, understand? Then nucleophile is the third influencing factor. So SN2 reaction depends upon the both concentration of alkyl halide and nucleophile. Therefore, nucleophile concentration increases, then rate of reaction is also increases. Then the solvents are the fourth influencing factor on the SN2 reaction. The polar aprotic solvents are very good for SN2 reaction. Polar aprotic. Aprotic means there is no proton. So there are DMS, DMSO, DMS, DMF, DMFH, APM, HMPA. Right, understand? Polar aprotic solvents means dimethyl sulfoxide, dimethyl sulfide, dimethyl formamide, dimethyl hexamethyl phosphoramide. These are the polar aprotic solvents. These polar aprotic solvents are useful for SN2 reaction. Then next, heteroatom or carbonyl group is present at alpha carbon, which increase the rate of reaction, and vinylic and aryl halides do not undergo SN2 reaction.